So I'm going to follow these three steps. The first thing I'm going to do is I'm going to find the magnitudes. This formula is in the data packet. It's under gravity or something like that, right? That the G is G, big G, M over R squared, right? Then we're going to find the direction, which in this case will be an angle. And then we're going to do vector stuff. Okay, so the first thing I'm going to do is let's find the magnitudes of these guys right now. Actually, I'm going to draw the direction. So remember that gravitational vectors are straightforward. They are toward, so the gravity field of A is toward A. The gravity field of B is toward B. Okay, that's pretty straightforward, right? Okay, so let's find the gravitational field due to A, just the magnitude, right? That's going to be GM over R squared, so 6.67 times 10 to the minus 11th, right? Times what's the mass of A? A is 1.6 times 10 to the 12th. And then divide by, and really let's see, it's 1, 2, 3 over 1 up, right? So it's the square root of 3 squared plus 1 squared, right? And then that whole thing is squared. Okay, now remember the squared gets rid of the radical, so you don't really need to do the square root of the radical when it's a squared like that. Okay, so let's figure this out. 6.67 e minus 11 times 1.6 e12 divided by parentheses 3 squared plus 1 squared, end parentheses. 10.672 newtons per kilogram. Okay, and we'll have to figure out the angle here in a second. Let's see. And then let's find the gravitational force due to B. That's going to be 6.67 times 10 to the minus 11, right? And B is 3.9 times 10 to the 12th. And then that's all divided by, let's see, what are we? 1, 2, 3 over 3 down. So 3 squared plus 3 squared. Now really what's in the denominator is the square root of that, and then that is squared just like this, right? So 6.67 e minus 11 times 3.9 e to the 12th divided by parentheses 3 squared plus 3 squared. And I get 14.45. 45, I'll say 452 newtons per kilogram. Right? Now we got to figure out the direction of these things, right? So let's figure out these angles here. The first one is this angle here. What is that angle there? And I think that's the inverse tangent of 1 divided by 1, 2, 3. Inverse tan of the opposite over the adjacent, right? So tan minus 1 of, it's going to be definitely an adorable angle, right? So second tan of 1 divided by 3, 18.43. All right. And then this guy right here is 3 over 3 down, so this is a 45-degree angle. 45 degrees below, right? This one's above. All right. So now we're set. Now we can add these guys up, right? So G A GB wingy wing. Oh, that's really good, I think. Okay, so GA is going to be this guy, right? The 10.672 up and right, right? At 18.43 degrees. Okay, so let's draw. And then we'll do X direction. We'll do the Y direction. And then B is equal to 14.452. And then that angle is 45 degrees, right? And this is down. So this is going to have the components of B are to the right and then down. So this is going to have a positive x. B is going to have a positive x and a negative y. This guy's going to have a positive x and a positive y. Right? Because this vector is up and to the right. This one's down and to the right. That's the only difference, right? Okay, and then I'm finding the angles with the x-axis. So this will always, cos is always the one I use to find the x component. So the 10.762, let's get that number there, and then let's get the 18.43. Okay, so I'm going to take the 10.672 cos of that angle, and I get 10.124. And that's in the x, and then the y, I'm going to take that same number, 10.672, sine of 18.43. This will be a smaller number, 3.375. Newtons per kilogram, right? All right, so let's see. That makes sense, right? Okay, so let's see. This guy's 14.452. It's 45 degrees. These are going to be the same number, right? So let's get the 14.452 number. There it is. And go cos 45. And I get 10.219. And this is 10.219 because it's a 45 degree angle, right? It's the same x, same y. Our y is negative because this is down and to the right. There we go. Okay, so now we're set. Now we can just add these guys up. So I'm going to take this guy plus this guy, 10.124, and I get 20.343. In the x direction, these are newtons per kilogram. And then this guy is the opposite of this 10-point thing, right? Plus 3.3 whatever. This is negative 6.844 newtons per kilogram y direction. All right, so now we got to draw a picture of this guy, right? So it's like, whoa, over and down, and then this. Oh, that's fairly good for me. Okay, so this is 20.343. This is 6.844. And the hypotenuse is going to be the square root of 20.343 squared plus, and I got to put this negative number in parentheses because of the dang TI calculator. All right, here we go. Just be careful there. 21.46. 4636 newtons per kilogram. Okay. That's my magnitude, right? And then my angle is going to be the inverse tan of 6.844, the opposite side, right? Divided by the adjacent side, 20.343. There we go. Okay, so second tan of the 6 number thing divided by the 20.343. I'm getting 18.59 degrees. Right, so this is 18.6 degrees would be that angle, and then this we'd have to round this to 21.5 newtons per kilogram. Well, look at us. That's not so bad, is it? Just keep in mind, it's just like force, only this is like in the subjunctive, right? If there were a mass there, there would be a force on it, right? Again, just find the magnitudes like this, right? Figure out the directions with inverse tan. And then just be careful about, the way I do it is I always find the angle with the x-axis
If I do that, then cos always gives me the x and sine always gives me the y. I just have to be careful about plus and minus, which isn't all that hard. Just think about it. Yeah. All right. Happy hunting.